Welcome to the next lecture. It is Are We There Yet? And the quote that we have is that I'm so fast that last night I turned off the light switch in my hotel room. It was in bed before the room was dark. So we're jumping into this. It says students will be able to algebraically manipulate this equation. So we've seen this equation before, and we're going to learn how to solve for different variables besides speed. And so we want to solve for unknown variables. So what we already know, the slope of a distance versus time graph gives you speed, and speed can be calculated using the formula speed equals distance all over time. What we learned in the lab, the distance can be predicted given the speed and time, and your brain does these calculations when catching, avoiding crashes, and investigating traffic. And so we kind of understand this, so we're going to try to put a mathematical perspective to it. So, using a speed versus time graph. And so when we're looking at this, you can obtain distance and time information as well as speed from this graph. And this is our distance versus time graph. And so we can look at all the different things. If we want to read it, we can find distance, we can find time, and if we calculate the slope, we can also find the speed. So finding the distance, what we can do is to find the time and draw the line straight up to the slope and then across to the distance. So if I know the time, I just go straight up and then I go across, and there's my distance, and that will give me the distance if I know the time. We can find the time by, all we have to do is find the distance, go straight across, come down, and that will give us this time. And that will give us a way to find distance and time on that graph. So let's look at our first example. It says, what would be an appropriate title for this graph? When we're looking at it, we have our distance, which is going to be our y-axis, which we know that's the dependent variable, and then our time, which is our x-axis, so we know that is the dependent variable. And so when we're looking at this, we can say that this is a distance versus time. And if we know any more information about it, we can say distance versus time of a specific investigation. So we can look at that. The next example, it says, what time will the object reach 80 meters? So we can look at it, and we know that 80 meters is right around here, right really close up to the top, and so we can just go straight across, which will be about right there, and then which is right about there, and then what we can do is just go straight down, and so it's kind of right, kind of didn't draw a straight line, but right in there, which is halfway between 80 and 100, which would be about 90 seconds. And so we could say that at 80 meters we'll reach that in about 90 seconds. And our mastery level says, how far does the object travel in standard units in half an hour? So we see that this is time in minutes, and so what we want to do is we want to find it in standard units, so that means in meters. So when we're looking at half an hour is about 30 minutes, so we go straight up, and then we look at our distance. Distance is going to be right around, at a half an hour, it's going to be 6 kilometers. And we know that there's 1,000 meters in a kilometer, so it's going to be 6,000 meters. Now, algebra. Sometimes you're interested in distance or time, not speed. I know that algebra makes our life much easier, and there's no need to memorize multiple equations. So that's how it makes our life easier. If we know a little bit of algebra, we know that we don't only need one equation, and then we can solve for multiple equations from that one. So rearranging the equation, start with your equation. Speed equals distance over time. Okay? We can multiply both sides by time, and what we see, those guys will cancel, and we see that distance equals speed times time. That will give us the distance. Then we can take that equation, divide both sides by speed, and see that those guys cancel, and then we see that time equals distance all over speed, and that'll give us time. So we can solve for each variable if we can rearrange the equation. So let's try an example. It says, what does algebra, or why does algebra make your life easier in this class? Because you only need one equation, and you can solve for multiple things using that one equation. Our next one, it says, write 3 different versions of the speed equation and describe when you would use each. So our first version is going to be speed equals distance all over time. That is when we're solving for speed. We can rearrange this, multiply both sides by time, and we get distance equals speed times time. And then we can take that equation and divide both sides by speed, and time equals distance all over speed. So here's where we'll be solving for speed. This is where we're solving for distance, and this is where we're solving for time. Next question. It says, how far will a baseball travel, or will a baseball traveling 35 meters per second travel in a 4.8 second time period? So when we're looking at this, how far is going to mean distance. So we know that our distance equation, distance is going to equal our speed times time. And so what we can do is we take our speed, which is our given. We're solving for our unknown, which is distance. Here's our equation. Substitute everything in. 35 meters per second, a time of 4.8 seconds. And when we do this, what we'll get is we'll get a distance, and solve it all out, of 168 meters. And looking at a mastery level question, it says, how long in standard units will it take a car traveling 60 miles per hour to travel 1,500 meters? Now the problem that we have for this are given, we have a distance which is not 1,500 but 15,000 meters. We have a speed which is 60 miles per hour. We need that in meters per second. And this is a common conversion. So 60 miles per hour, per 1 hour. So to do this, we can set it up. And this is a common conversion, so it's probably good that we know that 1 mile is 1609 meters, and 1 hour is 3,600 seconds. So anytime you come across a mile per hour and you need it for meters per second, a quick way to do this is just take that number and multiply it. Take that number 60 and multiply it by 1609 and the divide by 3,600. Quick, easy way to do that. And so when we do that, what we'll get is we'll get our speed in 26.8 meters per second. So there's our given. Our unknown, it says how long. So guess what that is? That is time measured in seconds. Our equation, since we're solving for time, we rearrange our equation so that time equals our distance all over our speed. And we go ahead and take this, plug everything in, distance of 15,000 meters, all divided by 26.8 meters per second, and that will give us a time of 560 seconds.